Examples of acids and bases in the Bronsted-Lowry realm. I showed you an example in the notes, and I kind of want to go over some more examples to make you feel more comfortable. Feel free to pause me and try it yourselves just to double check your own knowledge. We're going to go over quite a few examples. So I'm going to give you, as we mentioned, Bronsted-Lowry acids and bases come in pairs within one equation. If you look at an Arrhenius acid, if you look at HCl, you can say HCl is an acid because when I put it into water, I increase H+. Okay, so I don't have to have a base for the Arrhenius definition. Here I do. For the Bronsted-Lowry, I have to have both. So whenever you have some sort of acid-base reaction, you will be able to identify an acid, a base, a conjugate acid, and a conjugate base. So let's try to identify within these. Well, we have three examples here. Which one is the acid? Which one is the base? Which one is the conjugate acid? Which one is the conjugate base? So I'm looking here. I usually start with the acid, and acid we define within the Bronsted-Lowry realm as the species that donates an H plus. So if I'm looking here of what transpired, HF gave up an H. So HF is going to be my acid. Whatever it becomes the conjugate base. All right? And whatever it donated to becomes the base. And the base is what we define as something that receives the H plus from the acid. So this receives an H plus. Yep, it becomes NH4 plus. It received it, and this is going to be my conjugate acid. Okay, let's look at another example. Again, pause me, try yourselves. The cyanide ion reacts with water to form HCN and OH minus. This is HCN. It's hard to see. This is HCN. And again, I want to identify acid base, conjugate base. So whichever one donated an H plus. Well, this one doesn't even have an H, so it wouldn't be this one. So this is the acid. This is the acid. This is the base. Whatever becomes out of this is the conjugate base. So H2O gave up an H, becomes an OH minus. So it's a conjugate base. Makes sense that OH minus is a base because that's what we define bases in the Arrhenius definition is, in the Arrhenius realm. And whatever is left here is the base, and it becomes the conjugate acid. Okay, and this makes sense. If I were to flip the whole thing, HCN now is the acid. It gives up an H to the OH minus, which is the base, and this becomes, this becomes this, and this becomes that. It's exactly the same thing if I flip it. Okay, I just move the C's over. Okay, let's do another example here. The carbonate ion interacting with water. Water is the one, again, giving up its H. And this is the acid, therefore this is the base, the conjugate base. This is therefore the base. And again, this will be the conjugate acid, whatever the base becomes. Okay? H2O is not always going to be an acid. Sometimes it acts as a base, as we saw in other examples. Okay? Let's look here at this example. I'm giving you acids, and I want you to tell me what the conjugate bases are. Okay, so that's all that this is really asking is for you to just, well, acids donate H pluses. So what happens when an H plus goes away? Well, this becomes NH2 minus. This becomes, well, one H goes away, one H plus goes away, right? So this becomes S minus 2. This becomes SO4 minus 2. And here I get HS minus, okay? And that's about it. Hopefully this made some sense. Let me know if you have other questions and concerns, and we'll address them.